Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about starting an induction motor. So let's dive deep into it. So what exactly is the problem with quote-unquote starting an induction motor? Well, first you have to understand how much do we utilize induction motor. Well, in simplest term, it's backbone of our world, meaning the refrigerator you see to the air condition you utilize to water you drink to every Tom, Dick and Harry thing, including locomotives and many EVs, all of them rely on induction motors. So you have to understand from pumps to air condition to refrigerator, everything has induction motor. So it's one of those things that we have to handle properly. Failure to do so has consequences. Now, what is the issue with this? If this is a reliable motor, we have been using it for almost a century, what exactly is the problem here? Well, problem is that it has some serious issue while you start it. Basically, the moment you turn it on, it's the most destructive there is, basically in its whole lifespan. Meaning, at the moment you turn on the switch, it destroys everything that is connected to it. Why? It is basically a coil. Basically, if you connect, take a multimeter, put it in continuity, you'll always find it's connected. It's like, it will give, because it's an inductor, it's connected. Now, problem with that, because these things are designed to be high amp devices, meaning they could be consuming 4 amps, 6 amps, 50 amps. So the resistance is very low, meaning the moment you turn it on, it's a dead shot between live and neutral. So, and phase to phase, if you are talking about 3-phase motors. So the amount of energy rush that happens is bonkersly high. And meanwhile, that's just one reason. There are some other electromagnetic reason why it's even more worse than that, but you get the point. Like, and the same thing happens with transformer also. So whenever you have a substation that is distributing energy to a lot of step down transformers, they never go, let's all connect all the transformers, even though it's rated for that. If they did that, the big transformer in substation will go kaboom. So to make sure that boom does not happen, they're like, okay, start 1, then let few seconds to stabilize, start 2, inrush will go dissipate, wait few seconds, then start the 3rd. That's how they have to do it. So be mindful, anytime you are talking about an inductor, you're like, oh, it's resisting change. It's like at the first instant, it's literally a dead shot. So you have brutal inrush, and this inrush has very serious consequences. And how much we are talking about here? Well, you have to understand, let's say take a motor, and let's say that motor has a running current of 6 amps. Now let's 6 amps will become your X value. So that many amps, X amps is consumed by the motor while it's running. That's what you see in the nameplate. Problem is the inrush could be 4x to 15x higher than that, meaning the surge that this puppy dumps into your grid, into your electronics, into your generator, it's brutal. So you can see, and then it will stabilize. Now, why the heck it stabilizes? If it's a dead freaking shot, why the heck it does not melt? Well, it does try to, that's the inrush current, but the moment the rotor starts to rotate, it creates what we call back EMF. Back EMF is like, hey, chill bro. So back EMF chills basically the inrush current, so to say. And again, there are far more steps to it, but these are the simplest way I can explain. And be mindful, this applies to transformer also. And that's a big issue for people who deal in audio also, because again, audio transformers have huge transformers inside. And if you do not have mitigation strategies, it will cause, again, if it's a small enough unit, your grid can handle it. But if it's a big enough unit, yeah. So there are some serious problems of having induction motor everywhere, and each of them are putting surge into it. So it's a serious issue. So the cheapest and the simplest option is NTC Thermistor. Now NTC Thermistor is like, if you have motor small enough, for example, like this is a compressor from a refrigerator. I have something very similar running my fridge. Now the fridge, I used to think the fridge used to consume a lot of power because none of us ever connected a refrigerator to our inverters. Now in India, we have power issues in some states. So inverters are a normal thing. We just have a system which basically takes the AC, makes it into DC, charges the battery. And when the power goes away, it takes the DC from the battery and then gives us AC, and we run our appliances. It's a common thing. 6 years ago, when I started to run this channel full time, I bought a bigger system that had like, 2 batteries, as in like 12 volt, 200 amp hour batteries. And I had like 1600 watt inverter. It's a normal thing for us. But even though it's normal, we rarely have the idea of like connecting fridge to it. The reason for that is I did that. I connected my quote-unquote old refrigerator that is 15 years old to, once I opened it, looked at the back of it, it had a nameplate, and nameplate said like, hey, it's only going to consume 80 watts. I'm like, dude, the small inverter I have, that's 600 watt rated. And even the VA is like 1100 VA. So it should be more than good enough. Yeah, it fried it because of the inrush. So these things have very ugly inrush. So if you're talking about something small that has very small running current and you do not have boatload of money, the best thing to do is put a NTC thermistor. Be mindful, I'm physically doing it and I need to do far more experiments to definitively share that, but more than enough people have done it, and I think I have to add 2 more NTC to get the right ohms needed to suppress it. Now it's a passive component. You just buy a disc like this. It's a passive component. That's the good part. No interactive circuit needed. Nothing. It's just a stuff you put in line to the mains. Now it does require cold start. Let that be very clear. You cannot have it in the main plug of the fridge. It has to be before the basically compressor, and it must be where compressor goes on and off, duty cycle. Without it, if you have even a little amount of current going through it, it will be hot. If it's hot, it will not work. So what you're supposed to do is let it be at ambient temperature. Basically this, you put a multimeter, it will say, let's say for example in this scenario is 10 ohms. So it will show 10 ohms. But the moment you start the motor, 10 ohm resistor is there. It will tame the inrush current. After that, current is still flowing, right? You have not disconnected it. Current is still flowing. It will start to heat up. 10 ohm resistor, it will heat up. So what is the benefit? Negative temperature coefficient, NTC. It's negative, meaning as it heats up, the resistance goes down. Yes, that's why it's such a weird thing. Negative, it goes down. So benefit, it starts to become very low resistance path, meaning it will start as 10 ohms. While you're running it, it will go down to as low as milli ohms, meaning it's invisible. From your circuit point of view, it's invisible. That's why you cannot just put a normal resistor there. That will tame the inrush current, no problem. It's just that after that, it will be like, yeah, it's a heating element that you have there. That's why we do not use that. NTC is like a big ass resistor that magically disappears once it actually heats up. So it's a simple system. It's utilized everywhere. Again, you can find this in audio equipments also, or sometimes in small transformers. I have not seen it in big transformer, but I've seen it in big motors. But generally, people don't recommend using it for big motors because again, at that point, it's like, bro, get into other better tools. I'll explain more that. But NTC is the simplest, cheapest option you have to tame inrush current. Now, be mindful, many people have to use tools. Tools generally utilize universal motor. They also have inrush current. In those scenarios, these things are lifesaver. I have linked a video down below where a gentleman just makes an extension box and it's like, plug it into inverter, plug angle grinder in inverter, turn it on, angle grinder tries to draw power, inverter trips into overvolt. Put NTC in line, voila. You can run your power. And be mindful, it's just you starting is the issue. After it starts spinning, no problem. So cold start, resistance is very high, and as the current starts flowing through it, resistance goes very low. Now, it does not go to zero. That's why even in audio circuitry, you generally will have a relay that removes it. It's like, yeah, it's let's say milli ohms, but what if you have no ohms? So we generally disconnect them. But if you do not, it's not an issue. That's why I said, like, for small systems, it's generally preferred. It's the cheapest system. However, be very mindful because it does require to cool down in order to gain its ohms back. It's not suited for rapid start and off. Basically, if it's a good for duty cycle, it's like turn it on, wait, like let the compressor run, it heats up, everything is fine, turn it off. Again, you will give some time for this to dissipate all the heat away. Once it dissipates the heat, it's like, okay, now I'm back at 10 ohms. Again, the controller says, starts the compressor. It's like, okay, it tames the inrush. So it does work. It's here. It's real. You may have equipments that already have this, but it does not allow you rapid start and off. Again, minutes, if you require minutes, depending on the temperature, it may be 15 to 30 minutes before it cools down to its operating temperature. So NTC is the cheapest, thermistor is the cheapest option that you can do. And for many people, it's just like, it's more than good enough. Now we come to the soft starter, when you are talking about some serious power load. So soft starter allows you to do what we call soft ramp, meaning when you compare to NTC, NTC is just a big ass resistor that dissipates that heat. Here, there is no inrush. Now, like, wait a minute, how the heck there is no inrush? Again, isn't it a short? Yes, absolutely it is short. But what it realizes is like, hey, what if I slow it the voltage wise? Basically, if you take a sinusoidal wave that we get from our mains, it's 50 hertz or 60 hertz. So voltage will always go to 0 point and then it will slowly start to ramp. What somebody figured out is like, what if we tame this? Meaning you do not let all the power go. Basically 0 volt goes there and then it goes to 10 volt, then it stops there. Then it goes to 20 volt, stops there. And then it stops 30 volt, 50 volts. So basically there is a ramp. Rather than turn it on the moment the wave goes to 200 volts, it draws that much power. No, you do not allow it to. So that's how we can limit the inrush current. This is the most famous way of doing it from 1950s to 1980s. So, and be mindful, they are still sold, they are still a thing, that this is the easiest way to tame the inrush current, and it removes it. Basically, there is no inrush. It's not taming, it's suppressing. It's like, yeah, there is no inrush. So It reduces inrush. It reduces the mechanical shock also, meaning whenever you have that kind of inrush, you must see the induction motors generally are like there's like now be mindful, imagine this is a inverter, basically this is a elevator where you have a giant motor on top. It could be 10 horsepower or 20 horsepower like that. So it's going now what is that means? That simply means that shaft is trying to exert energy into the gearbox. Now gearbox is like, bro, chill. That causes chatter, that causes wear and tear. So yes, your equipment is also suffering just because of that electrical side. It's not like, okay, only the electrical side is suffering, the mechanical side also suffers. So that's why you prefer soft starter. It's like, I got this, fam. You just let the voltage slowly rise. You control the phase angle and you're like slowly rising it, and then it's like, I got this, I'm good. So this reduces the inrush current, reduces the mechanical shock to the system, and gives you power stability, because the surge that we are, and the refrigerator I was talking about, that has a tiny compressor. That tiny compressor somehow managed to fry 600 watt rated old inverter. Now again, I have recently got solar, and this is like completely isolated. It takes DC. Even from AC, it makes it DC. Then from DC bus, I get a clean AC sine wave output of it. Whenever that refrigerator runs, I can feel it. Why? Because my UPS goes, because for few milliseconds, the voltage dips, because that's how much inrush is there. Again, I'm experimenting with NTC to tame it, and I'll share if it's good. So it removes that the dip that happens. When be mindful, when you're talking about big motors, that dip happens to your local transformer. And if it's a really big motor, like used in clinker plants of cement of mills, yeah, that will transfer to the like literally power plant. That's how much inrush it has. So for those sort of scenario, you need this. Like there is no scenario where it's like, oh, I'm running like 10 megawatt induction motor. Is like people are like, bro, put a goddamn soft starter on it. Or back in the old days when we did not had soft starter, we literally had a smaller motor that turned the main motor slow, so the back EMF will generate far more quickly, and that was the simplest way of one, you could say, to tame the inrush current. It does not work that well, but if you had nothing else, that was the only option. So, and this also has another benefit. Once you start the running circuit, once you control the phase angle, once it has the back EMF, it can disconnect. Meaning, generally you will have the electronic side of it, thyristor firing control. Once you disable it, like, okay, done, it can run on the mains without any issue. So even if these things fail, they also have the option, you can just disconnect it and run the motor. But again, it will give you the hard start. It will not give you the soft start. But in those sort of scenarios where it's like, hey, it's better to have a motor running rather than a down, this do have that option. A very simple device. It only comes online when it needs to start and nothing else. And these are generally preferred where you do not require speed control. Meaning, yes, in principle, it can speed control by reducing the voltage, but that's not recommended. So people do not use it for that. So this is just like, hey, I have a big ass motor. It has a lot of surge, and be mindful, surge is also the primary reason why motors do not last very long. Technically, they should last forever. There is nothing that is wearing down. Why the heck it does not last? Enamel coating on the coil is going through surge. It's not desirable. So it's preferred for no speed. For water pumps, it's like, hey, I do not need to control. The water pump is designed, the propeller, the impeller is designed for 1 RPM. I do not need to control it. I just need to like slowly start it. And be mindful, that also helps in cavitation reduction. If you have a giant shaft connecting to the basically water body and going as quickly as it can, yeah, that creates a void behind the blade. And the void is, nature does not like void. Water is like, let's go boom, boom there. It goes kaboom there. So we call it cavitation. That destroys metal. Yes, it will annihilate metal. Giant thick metals can be annihilated. So you do not want that. So soft starter. So basically all you are doing is taming the voltage. You are not giving the motor 0 to 220 volt. No, they are like 0 to 10 volt, stop. 10 to 20 volt, stop. 20 to 50 volt, stop. So that's how basically you are letting back EMF build up, letting everything equalize before you give full to 20 volt. Very effective, very reliable systems. And again, they bypass themselves once they have already done this. So they have very long lifespan. So soft starter is another way of actually taking care of the motor and having, basically this is how you have all industries running. Then we come to the granddaddy. The granddaddy is variable frequency drive. This is basically somebody is like, hey, we are already soft starting it. Might as well add integrated circuit to it. So from 1980 plus. So this is full two-stage conversion. You take AC, you make it into DC, then you take DC and then make again AC. These are sometimes also called inverter drive. Like, why would you take AC, make it into DC, then again make AC out of it? Well, this gives you one awesome thing. It gives you control over RPM and torque independently. Let that sink in. You have a motor and these puppies can let you like, hey, I see you have a motor. What RPM you want? You're like, bro, it's 1500 RPM motor. It's like, no, I got this. What RPM you want? You can literally have it, hey, only rotate it at 500 RPM. It can do that. Like rotate it at like, 1500 RPM. So let's say rotate at 1600 RPM. It can do that because it's controlling the frequency. And if you pay attention to any motor made by any company that is selling in multiple continents, they generally will have two nameplates in one. So they will say at 50 hertz, it's at 1500 RPM, at 60 hertz, it's 1600 RPM. Because again, change the frequency, change the rotation speed. Frequency directly couples to RPM. So RPM is controlled. That's why once you are converting from DC to AC again, you have the luxury of controlling the RPM. So you must have seen that spindle motors that are there in CNC machine. They are induction motor. How the heck they are rotating at such a ludicrous speed of like 20,000 RPM to 50,000 RPM? Like, how is that possible? VFD is like, bro, I got this. So input current would be like basically grid frequency would be 50 hertz, and the VFD will like, I got you, fam, 500 hertz to the motor. And whenever you're talking about the electric vehicle, this is the core of electric vehicle. It takes the DC from the battery and then makes AC that is required for the motor. So that's how they control it. So why do you think that DC cars, basically the DC motors that we utilize, or AC induction motors we utilize, has so much torque? Well, because the VFD is sitting there and it's like, hey, if I give it RPM, the laws of physics will stop me to actually accelerate the car. But what if I give you torque? Basically torque being voltage. So it gives as high voltage as, again, within the safety limit it can give. So benefit is the motor does not have like a lot of rotational RPM, but it has enough oomph that it will actually break through the inertia barrier, and then your car picks up very quickly. So that initial few seconds, that's why electric vehicles are so quick. That initial going from 0 to 10 kmph, that point is the sweet spot for going to full torque, dead torque. So you get a lot of torque, and after that it's like, okay, motors are rotating, everything is fine, let's increase the RPM. So your frequency will start from, let's say, 50 hertz, and it will slowly 60, 70, 80, 90, 100, 400. That's the last I have seen, 400 hertz. So that's why people go through all this dual conversion nonsense. You have AC, then you make it into DC, then again you get AC out of it. So you take AC, goes through a bridge rectifier phase, you have giant capacitors and inductors to have basically act like a reservoir of DC current. Then you have your switch elements that give you the three-phase power out of it. Again, it could be done for a single phase also. It's not limited to three-phase, can be done. So modern units that you can buy right now, it also, be mindful, because this came after Softstarter, they were inherently a Softstarter also. Because you can see it can does PWM thing. It has a duty cycle control precisely, where it's like, hey, motor, start rotating. It's like, I'm 1 horsepower motor. VFD is like, no, you're not. You are 0.1 horsepower. Rotate. So there is no what you call back inrush, huge inrush. There is no, it slowly starts to spinning. The moment, again, many of them have feedback loop where they can figure out, it's like, I think motor can handle it now. Now it gives the full power. So it does that. Soft start is already there. All VFDs have that nowadays. And again, you can even control how long it takes. So it could be like 5 seconds to start to full RPM, 15 seconds 0 to full RPM. That's up to you. You can tune it very precisely. On top of that, modern units that are made after, let's say, 2010, they also improve power factor also, because induction motors is inherently dirty, quote unquote, when it comes to power factor. These puppies like, I got this. So because if you know about commercial energy, you know that they also charge for power factor. You want to make sure that power factor that is going to the transformer is very clean. And power factor has the ugly habit of coupling, meaning the substation knows that you have a dirty system. So they're like, hey, what if we clean it at the source? Ta-da! And be mindful, benefit of having improved power factor is the fact that you no longer even have that much harmonics. And why you had dirty power is simply because of this phase. The bridge rectifiers are ugly when it comes to power factor. They are very ugly, they are very noisy, they create harmonics. So modern systems have a very active bridge rectifier setup where they actively control it and then match the sinusoid of the input current. So input current is at 50 hertz, they'll match it properly, clean energy draw. So benefit of this is now modern VFD gives you much higher yield on the same amount of energy, because you are not wasting so much energy on power factor, inrush current, and your equipment lasts much longer. So a motor that was like barely lasting 10 years is like, bro, I got this. 10, 20 years, no problem. So it is a very complex system. Let me be very clear. Be mindful. You have 2 stages of conversion. It is complex as AF. However, because of the development of solar, especially in countries like India and China, because farmers wanted water pumps. That's their primary bread and butter. that shall have good water pumps. Water pump consumes a lot of power, so you need a lot of solar panel. But guess the giant inverters, giant batteries to run a pump would be too expensive. So somebody figured it's like, hey, we have DC to AC that runs the motor. What if we give the DC from solar panel directly here? That's how we are running all the basically water pump in India, solar water pumps. So they have solar panel, VFD, motor, no batteries required. Sun comes up, it automatically drains the solar energy, and no problem. So a lot of innovation happened in low cost VFD. We already had high quality VFDs. Without it, there is no industry. So that part is sorted. It's just that for low cost, for 1 horsepower, for 1 phase motor, it did not used to exist. But after solar's boom, it is starting to become a mass commodity item, meaning you can just go and buy it. Still not free, but expensive. But it has come down in price, where it's like, okay, you have to call someone who has to call to Siemens or ABB to like, hey, there are 50 to 60 countries that are selling you now. So variable frequency drive, this is the final solution of taking care of the inrush, taking care of the power factor, everything. It solves everything except the price part. So what can we expect in the future? Well, reality is energy costs are rising. Why? Well, if you build a dam, the river dries out. The river dries out, the reservoir shrinks. The reservoir shrinks, you have less pressure on your turbine. Output is less. So yeah, that's there. Coal. The first layer of coals are super easy to extract. Almost at the surface level, you can just like free coal. But as you go deeper, as you dug deeper, the fuel consumption of the mine goes up. Now the coal is more expensive. And if you have to call your friend like Putin or OPEC, and now they have to import fuel that is expensive. So TLDR, energy is expensive worldwide. Worldwide energy is getting expensive unless you are dealing with solar or wind. So, and only those two. Nuclear does not apply. Nuclear is even more expensive. It only causes bankruptcy for the companies that install it. So fundamentally speaking, energy costs are becoming expensive. So how does people communicate for that? How do people accommodate for that? Well, we go to energy efficiency ecosystem. And again, India also had its own movement, so to say, to take care of it. Government initiated what we call 5-star rating, meaning if you have 1 star, poor, 2 star, okay, 3 star, good, 4 star, really good, 5 star, damn. So that's how we did. And be mindful, because it's such a drastic change that you are now measuring the efficiency of a device. Government had to do some concession, because again, if the Indian government was like, okay, now you make everything as efficient as possible, company would like, yeah, now everything is 10 times more expensive. So they needed a ramp up period. So the ramp up period was like, make sure you have 5-star rating in India, please check the year, meaning 5-star of 2018 is not same as 5-star of 2020. For example, this AC that is running right now, it's only 4-star, and I have another AC that is 5-star. Like 5-star would be better? Not really. Again, if you only look at the star, you will think, that should be better. But if you look at the stamp, that is 2016, this is 2020. So of course, 2020 has much higher standard to clear. So 4 here means EER of 4.3, while the EER of old 5-star was only 3. So you see, like year by year, government makes it more difficult to get that same 5-star. 5-star for you and I, but only thing we have to make sure is the year is right. So again, every country went through that, be it China, be it India, be it America, all countries went through this, where they are like, okay, let's make more energy efficient devices. So in that movement, the people realized very early on, induction motor, if we can tame this puppy, we got this. So all your air condition nowadays, it's almost impossible to buy air conditioner that does not have this term, inverter. What is inverter? DC to AC. What is VFD? AC to DC, DC to AC. That's why. So we call it inverter. Do not ask me why we do not call it VFD technology, but apparently somebody in the marketing thought that, VFD is a complex word, engineering word, hulululu. So let's call it simple words like inverter. It's just marketing. Let that be very clear. By design, if you open it up, you compare the schematics, it will be a VFD schematics. It may have some parts removed. It may be like, hey, it does not need to tamper with this. VFD is a flexible device. So inverter may be a cut down VFD, where it's like, hey, I only need these functions, rather than like, full ramp up, ramp down control circuitry and full this control, that control is like, hey, bare minimum. That could be true, but people have opened it up and it's like, bro, it's a normal VFD. So that inverter word simply means you have same induction motor as before, like same refrigerator I have. I could literally buy same refrigerator from same company. Again, 15 years later, it will like almost same size compressor, but the compressor will have a giant electric box next to it, which is the VFD, which it calls inverter. So this is basically VFD for consumer section. Be mindful, industrial consumers, they had VFD the moment it became available. They are like, okay, VFD can do what? Shut up, take money. That was real true for industry, not for you and I. But now it's true for you and I. We have inverters. Be mindful, now even washing machine has that. Sometimes now companies like, what if we get bit more, push bit more, and magnet prices are low enough? BLDC. So do a inverter. Whenever you're talking about inverter, that's what you're talking about. You have induction motor that can be tamed properly. Benefit, no surge. Another benefit, low power factor, meaning basically good power factor. You want power factor of 1, generally that's not achievable. But if you have like 9.99, ultra good. If you have 9.5, more than good enough. But if you are running a raw, naked induction motor, that could be as low as 0.8. So, or even worse in some scenarios. So this is a very good growth, and be mindful, this is good for everybody. Not only you benefit from having a less load, less electrical consumption. National grid also benefits. Why? Because there is no more surge. And be mindful, they had to pay for the surge. They had to reinforce the cables. That's why commercial people, they have to pay for the power factor. Power factor is not magic. We do not have superconductors. So it does turn into wasted energy. You do not want to waste energy. Power factor correction, awesome. Not having surge, your transformer lasting much longer, really good. Less wasted heat, really good. And again, coils lasting longer, really good. So everybody wins once we start to deploy this technology. Only complication is that it's far more complex. So while the motor could last now, much longer, the chances are the board could poop out before that. So that's there. However, in India, I have noticed like fridge inverter, AC inverter, washing machine inverter. The only thing I have not seen inverter based is water pumps. Like water pumps are like still stuck in the old days, where it's like you buy a pump, you decide you want to buy a soft starter for it or VFD for it. And unless you are dealing with solar plate and direct VFD, that is still not sorted. So that's the issue part. Other than that, all things are sorted. And as you can see, this is the system that many places, including China and India, you will see that you will just have like giant panels and water is coming out of it. It's like simply because panels, VFD, motor. So this is a very good direction that we are moving towards, having a less surge, having less blah blah blah, less harmonics. All that thing is directly helpful to everybody. It's not as big as like going from like coal to solar, but it is helpful. And again, it helps your pocket. So that's it. So this was my presentation on how to start the goddamn induction motor. Hopefully you have liked it, learned from it. In that case, please click the like button, share to amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.